Hi guys, today we'll be solving a question on ex-meridian stars. My previous video has discussed the ex-meridian method using the sun as a celestial body, and this video is about using a star as an example of a celestial body, and we'll be using ex-meridian method to calculate the observed latitude. Alright, so I'll get straight into the question. The question says it's 2nd of March 1992. It's PM at the ship, so it's evening or night of the ship, and this is the dr position given to you. The sextant altitude of the star Capella. Now Capella is the star's name. Capella is the star, and the altitude was 60 degrees 29.4 minutes. The chronometer time is given to you, and so is the error. The error is 2 minutes 6 seconds slow. The height of I is given as 48 meters. Index error is 2 minutes off the arc. These are the key information given to you, and using all this information you have to find the direction of the position line and the position through which it passes. Correct? So position line is also called PL, and this is what you have to calculate. Alright, so the first thing you'll have to do is you have to solve the ambiguity of the chronometer time. So I'm getting straight into the solution now. So to solve the ambiguity of the chronometer time, you first write down the chronometer time given to you. The chronometer time given to you in the question itself is 00 hours, 30 minutes and 12 seconds. Now what happens with the chronometer is it works pretty much like an analog watch. So when you look at an analog watch and you look at the hands and minutes, and you don't know, if you don't know what's outside, you don't know whether it's the time is AM or PM. So for academic purposes only, when you see a chronometer time in the question, you don't know whether it's, in this case, let's say 00 hours 30 minutes and 12 seconds. You don't know it's 12 o'clock in the morning or 12 o'clock in the afternoon, and because of that it's called an ambiguity of chronometer time. Now of course when you're on the ship, you're pretty much sure of what's going on your ship, but here you have to use the ambiguity of chronometer time to find the GMT. So the first thing that you do is you write down the chronometer time given to you, and then you add 12 hours and write down another option here. So you add 12 hours to the hour clock and you write down the chronometer time given to you. So this is an alternative, it could be either or. Then because the error is slow, if the error is slow you will add the error. If it's fast you will subtract the error. So when it's slow, that means chronometer is lagging behind, so it needs to catch up, so you will add the slow error. So in this case the error is given to you as 2 minutes and 6 seconds. Once you do that, you get the time of 00 hours 32 minutes 18 seconds or 12 hours 32 minutes 18 seconds. Now you see the second written here. I'll erase this. Now you do this at the end, you will not do this at the beginning. The only reason I wrote this is so that I remember to point it out to you. Now once you get the GMT time, now you have to find out what's the correct date of the GMT and which is the correct GMT. To do that, you apply the zone correction. See the zone correction here. The zone correction is obtained from the longitude in time, or LIT. You get LIT by dividing longitude, the given dr longitude, by 15. In this case the longitude was 92 degrees 10 minutes. You divide it by 15, you get something called 6 hours 8 minutes and 4 seconds. This is the longitude in time. Now when you write longitude in time, you write the hours, minutes and seconds. But to base it on the zone, now to decide the zone, which is the practical way of timekeeping on ships based on your longitude, we cannot have individual time based on our individual longitudes. That will complicate the whole process, right? So for practical purposes it doesn't work. So we have something called the zone system. Now please watch my other videos about the zone system of timekeeping on the ships. So what we do is we use the LIT given to us as 6 hours 8 minutes and 40 seconds, and because it's only 6 hours and 8 minutes, the minutes is less than 30 minutes, we round it off to 6 hours itself, and that is the zone. The zone is plus 6 hours because we are in the east longitude. So when we are in the east longitude, we are ahead of GMT. GMT is behind us. When we are in west longitude, GMT is ahead of us. That means that the time at GMT is more than the time on our local ship. But in east longitude, that if you are in east longitude, your time will be more than the time kept on the GMT. So once you add the two cases, in 6 hours in both the cases, in one case you get 6 hours 32 minutes 18 seconds, in the other case you get 18 hours 32 minutes 18 seconds. And this is the zone time, or ZT, that I have written here. Also in some books they call it the ship's mean time, or SMT. Now once you get the ship's midname, this is the time that you have been keeping on your ship. This is the time on your clock. This is the time on your watch. Now how do I know which is the correct time? Now remember the hint given to me in the question is that it's PM at ship. That means it's evening, right? So if it's evening on the ship, in both the cases I see only one case where it's evening, and it's 2nd of March. So we know that it's 2nd of March evening. So I will put 2nd here. That's the 2nd of March. If once I put 2nd here, I know this is the correct GMT time or correct zone time. So I will cancel out the first case. I don't need the first case. That's not important for me now. Alright. And looking at the time, I know that in the zone time I'm only 6 hours ahead of GMT. If it's 1800 on my ship, it's 1200 hours at the GMT, so it's still on the same day. If it's still on the same day, I will put the date there as well, as 2nd. Alright, so at GMT also it's still 2nd of March, and it's 1200 hours 32 minutes 18 seconds, and that's why that becomes my correct GMT. So for the rest of the question, I will highlight this time here and the date here, and I will use this date and time to work out the rest of the question. Remember to use GMT and not the zone time. Some students get excited and start using the zone time, and that's a big error. Alright. Now using this date and time, I will find out my GHA Aries for 1200 hours for 2nd of March. Then I go into my increment section for 32 minutes and 18 seconds. I'll find out my increment. I will add the increment that I find. Increments are always added, never subtracted. And I will find the GHA Aries for 1200 hours, 32 minutes and 18 seconds. My longitude is given to me as east. I will add my longitude because the rule is if longitude is east, GHA is least. That means GHA is less than the LHA. So I will add the longitude to make LHA more than the GHA. Alright. Now why I am taking you through this is because when I will go into the Almanac, I will show you where to find out the individual information from the Almanac. Alright, I will show that to you at one go, otherwise I will have to keep going back and forth, and you might lose track of what we are doing here. So don't worry, I will go into the Almanac and show you where I get the information from. Alright. So you always add east longitude to the GHA to find your LHA. Now when you add 348 and 92, your total increases or becomes more than 360. Once it goes more than 360, you will subtract 360 from it. So if you add 348 plus 92, you will get something like 440 or something. So you will subtract 360 degrees. Alright, so LHA cannot be more than 360. And then you write down the answer. That's how I got my LHA. Then I will get my SHA star also from the Almanac. And then I'll show you. So I'll go in there and I'll show that to you. Alright. So once I go into the SHA star, I will always add the SHA star of Capella. Alright. SHA is also always added, and then you get your LHA star. I will also go into the Almanac and find out the declination. So what you have to do is basically when I'm pointing out this information to you in the Almanac, just note down that information, and then you can come back and compare my values from the ones that I've written here. Alright. So I'll go into 2nd of March for 1200 hours, and then I'll go into the increment section and I'll show you where all I found out the information from. Alright, so 1200 hours, 2nd of March. So I go into 2nd of March. I can see here I've highlighted it, 2nd of March. I'll bring this here. Now for 2nd of March, you can see. So before I do that, I can show it to you here itself, and I'll try to show it here. Alright, this is not doing a very good job here, isn't it? Sometimes these things work, sometimes they don't. I have no idea. Here you go. Alright, there you go. So for 2nd of March, this is 2nd of March here. Alright, I'll use the red marker so you can see. And this is the GHA Aries. And for 1200 hours, this is my GHA Aries. This is the one that I've noted down. Alright. Then if you look at Capella, stars are given here. Stars are here. And Capella is somewhere here. You can note down the SHA and the declination here. You can go and take it down at the same time. Right? So you got the GHA Aries here. You got the stars SHAN declination as well from here, and then I go into the increments page for 32 minutes and 18 seconds, and this is somewhere here. So I go into 32 minutes and 18 seconds here, and this will be somewhere here, right? And then I'll point it out to you again. So for 32 minutes, this is your, so this is for sun. Sorry, so I will take it out. So you have to go into the stars. So the Aries one, right? So this is the Aries. You have to go into here and then find out your increment for 32 minutes and 18 seconds. So that's how you get all the information for. So I didn't want to go back and forth, so I thought I'll take you only one time and then you can see. Alright, so this is all the information. You will see that the information I highlighted is the one that I have put down here. The longitude is given to you. You add in accordingly and then you get your LHA star. This is your LHA star. And then you can name your LHA. If LHA is 0 to 180, you name it west. If it's more than 180 to 360, you name it east. Alright. Once you get your declination, you know where you get the declination from. Now I'll work out the sextant altitude. Now sextant altitude is given to you as 60 degrees 29.4 minutes. Index errors of the arc. When it's off the arc, you will add the index error. If it's on the arc, you will subtract the index error. Now remember, this is minutes, so you will add to the minutes column. Alright, some students, they get excited, they add it to the degrees column, and then that's a big mistake. So you add the minutes to the minutes column and you get 60 degrees 31.4 in this case, because your index error was off the arc. Then you get your height of eye correction. Now I'll show you where you get your height of eye correction from, and I'll also show you where you get your total correction from. Alright, to do that, just assume that we have got the height of eye correction of 12.2 minutes. Height of eye is always subtracted. I will subtract my 12.2 minutes, and then once I get my apparent altitude, I can use this apparent altitude value to get my total correction for stars. Now remember, the height of eye is 48 meters and the apparent altitude is 60 degrees 19.2. With this information, I'll go into the Almanac and I'll show you where I got my information from. Alright, so to do that, you have to go back into the Almanac. And this information in the Almanac is normally obtained from the first page, first couple of pages from the Almanac. Now I have rearranged this Almanac digitally, so don't worry about that. Alright, so for 48 meters of height of eye correction, you can see that this is your height of eye table. Alright, and now you can see that this is the meters column. Right, and your height of eye is given up to 21.4 meters, but you can see there is a pattern here. For every 0.5 of a meter, you have the height of eye correction. So 0.4 to 0.5 of a meter. Right. So this is and then that's how the correction goes. Now for 48 meters, you don't have a correction. So you can't see a correction for 48 meters. Right. So what do we do in this case? Now in this case, there are two things that you can do. One thing is, of course, you can see that here it extends more. Alright, so if you see here, this goes on extending here. If it doesn't stop here, it goes on extending here. So you can see for 48 meters here, the correction is given to you as minus 12.2. So it's done. Alright, the second thing that you can do is there is a formula. I cannot remember a formula. I think it was somewhere like under root height of eye, and there is a correction there. I will not discuss this formula right now because I can't remember the formulas, but if you can Google it, you will find that there is a formula for height of eye as well. So if it ever goes more than 48 meters, you can Google the formula for height of eye, and when I find it, I will mention it in my next video as well. For now, I should have discussed it. I should have found it out before I started discussing it. So you can do that as well. So you can find out the formula for height of eye, and you can find out the deduction for that as well. So I'm just letting you know so that you can Google it and find it. Otherwise, you can find out here for 48 meters is minus 12.2. And then for total correction of stars, I told you that's about 60 degrees and something like that. So you can see the total correction of stars is given here in this middle column here. It's for stars and planets. And apparent altitude, for an apparent altitude value of 60 degrees or 29.2 or something, you can find the value somewhere here. Alright, if it's less than 60 degrees 26 minutes, you will find it here. So you can see these are the corrections given to you, and the negative sign tells you what to do with it. Alright, having said that, I come back here. So it was 60 degrees 19.2, so you got minus 0.6 as the total correction. Alright, so you subtract minus 0.6 and you get your true altitude as 60 degrees 18.6 minutes. With this true altitude, you subtract minus 90 degrees, or rather you subtract the true altitude from 90 degrees, and you will get your true zenith distance as 29 degrees 41.4 minutes. This is also called TZD in many books. It stands for true zenith distance. Now you see the north and south mentioned here. I'll come back to this later on, why I mentioned this here. Alright, I'll tell you how to name it later on. Firstly, we use the formula, a scientific calculator formula of cos mzx to find the mzx from the using the tzx, LHA, lat and dec. Now what is mzx? Mzx stands for meridional zenith distance. You can also write it as mzd, stands for meridional zenith distance. Now you see the formula here. All you have to do is just put in the values in the formula here. Alright, and then you follow my prompts. Put in the true zenith distance value, the LHA value, the latitude value, and the declination value. Then follow the prompts here, and you can see the values that I have obtained. And finally, using a cos inverse, you will get the mzx or mzd, it's called meridional zenith distance, value of 29 degrees 39.2. And that's the value you use to obtain the observed latitude. Alright. Now I'll go back to how I named my true altitude. Now how did I name my true altitude? Now true altitude is named here same as bearing or same as azimuth. What does that mean? That means where is the celestial body bearing from me as an observer? And how do I find out that? So basically you find that out by drawing a vertical line. Now when we say ex-meridian is very close to our meridian. It's not exactly on our meridian, but it's very close to our meridian. So we kind of assume that it's still very close to our meridian, so we can draw it on my meridian itself. That's my way of going about it. Alright, so I draw the celestial equator as a reference point. It's called equinoctial, that's Q. Then I plot my latitude. My latitude was 16 degrees 12 minutes north. Right, so my latitude from the question itself is 16 degrees 12 minutes north. So I will go north of the equinoctial and I'll put myself there. This is Z. That stands for observer's zenith, and that's 16 degrees 12 minutes north. Then I have my declination as 45 degrees 59.6 minutes north. That means I have to go higher than my zenith. So I'll go north and I'll put X here. X stands for the celestial body. So the body is north of me, right? This is me as an observer, and this is the celestial body, the star, Capella. It's north of me. So I will name it north. I will name my true altitude same as bearing, and that is north. True zenith distance or meridional zenith distance, mzx, is named the same way. It is named opposite to true altitude. Whatever you name your true altitude, it's named opposite to that. So if altitude is north, you will name it south. And that's why your meridional zenith distance is named south here. Right? And then you put down your declination, which is that you found out. The rule here is different names you will subtract. So both are not the same names. They are both not south or north. One is south, the other is north. So if they are different names, you will subtract the smaller from the larger, and then you name it based on whatever is the larger. In this case, declination is larger and it's north, so you name it north. Alright, so you get your latitude as 16 degrees 20.4 minutes north. Alright, then once you get your observed latitude, this is the position through which the position line passes. So one is the observed latitude, and the other longitude is that we use is the dr longitude itself given to us in the question. So if the answer that you need, you put the observed latitude and the dr longitude itself, because you calculate the observed longitude using the long background method that I have discussed in my other video. Once you get the position, You have the other part of the question asks you that what is the position line. So to calculate the position line, you have to calculate the bearing first, right? So to calculate the bearing, you calculate the component of A and B. A is calculated by tan lat dividing by tan LHA. Put in the values, get the value here. In case you ever get a negative sign in calculating A and B, ignore the negative sign because you have to name A and B. A here is named south because A is always named opposite to latitude unless LHA is between 90 and 270. In this case, LHA is not between 90 and 270, it is somewhere around 1 degree. So you will name it opposite to latitude. Latitude was north, so you named A south. B is calculated by dividing the tan declination by sin LHA. Put in the values, you get the value of 33.77. Again, if you get any negative values, ignore it. And then you name it same as declination. So if declination is north, you will name it north. If declination had been south, you would have named it south. It's named same as declination. Once you get A and B, write down the A and B values here, right? I didn't have to draw that, that was already drawn, so I will take this off. Alright, once you do that, you draw A, put in the A and B. The rules here are, if they are different names, you will subtract it. If they are different names, you will subtract it and you will retain the name of the larger. So you retain name of larger, that means if this is north is larger, you will name C north. In this case, north is larger, you named C north. If south was larger, you would have named it south. And because you have to subtract it, just subtract the smaller number from the bigger number and then you write down the C's value here is, right? Then you calculate azimuth. Tan of azimuth equals 1 divided by C times cos lat. Put in the value of C, put in the value of cos lat. Solve the denominator first and then divide 1 by it. Follow my prompts here in your calculators and compare it to the values that you get in the calculator. Do a tan inverse and what you will get is 2.5 degrees, which I will round off to 3 degrees, or you can continue with 2.5 degrees or you can make it 2 degrees because this 2.5. Why I round it off is because one day you will have to plot these bearings on the chart or on the plotting sheet in the exam. So you can't plot bearings of 0.3, 0.2, 0.7, right? Maybe some people might argue that I can plot a bearing of 0.5 by going in the middle of the bearing between two bearings. But still I would argue that try to take a round number. When it's 2.5, you can go either 2 or 3, but if it was 2.3, I would have gone 2. If it's more than 0.5, you round it off to the next number. So try to round it off to the next number or the previous number depending on the decimal place, but get a round number because these are the numbers that you can plot on the plotting sheet or chart. So in this case, I've rounded off to 3 degrees and I've named it north and west. How did I do that? North comes from C, value of C. So C was north, C, and I've named it north here, name of C, right? West comes from LHA. Alright, if you go back, you can see I have named my LHA as west because it was between 0 to 180, you see. If it's more than 180 to 360, I would have named it east. So you can see I have named it LHA is west. That's why I got my LHA, my west from. Alright, so north 003 degrees west is also equal to 357 degrees true. You know how that works. So if this is north and this is 360 or 000 and this is west 270, you are going 3 degrees west from north. You are somewhere here. This is 357. That's how I got my 357 degrees of bearing. Once you get that, just add 90 and subtract 90. Once you add 90, of course, this value goes more than 360. You add 90 and in this case you will get 447 and then you subtract it from 360. Don't keep it more than 360 and you get 087 degrees. If you subtract 90 degrees, you get 267 degrees. Now these two values give you your position line. So your position line will be in the orientation of 087 to 267 degrees. True. This is your orientation of the position line to the bearing of 357 degrees true. Alright, so this was a way of showing how to calculate the ex-meridian method of calculating the observed latitude using star as a celestial body. Hope this video helped. If you have any questions, please write it in the comments. And thank you again to all my subscribers and all the people who follow me and give me feedback. I really appreciate it. Thanks guys.